Howdy Huskies, how are we doing today? It is Mr. Naughton out in the leadership room hanging out with you. We're going to do some lovely polynomial functions today. It is 2-3. Make sure you've clicked on the right number, the right video, and let's get this party started. So we got our review questions. Let's go ahead and get those going because those are going to sort of get us into the direction we're flowing today. So the first is find the vertex. So when we go ahead and we find the vertex and it's not in standard form, when it's not in vertex form, we go ahead and we want to find that axis of symmetry, which is negative b over 2a. That's generally the plan. That's a lot of work. So I'm going to go ahead and look at this really quickly, this equation. And I'm going to notice that this has got no b term. So if I were to think of my standard equation of ax squared plus bx plus c, it's got no b term. And since it's got no b term, I can actually change it really easily into y is equal to a x minus, whoops, put my squared in the wrong spot, x minus h squared plus k. Because what's the difference between x squared and x minus 0 squared? Not a whole lot. So x minus 0 squared plus my k, which is 8. So then we go ahead and go change keep. So our vertex is going to be 0 because there's no such thing as a negative or positive 0, and 8. So that is our vertex. That is review question number 1. Let's go ahead and find the minimum value for number 2. Now, minimum value is just a fancy way of saying what is the y part of your vertex. So we're looking for the y part of our vertex. The y part of our vertex is the k. So this is kind of easy peasy lemon squeezy. Our y value, our minimum value, is negative 17. Booyah. Now, like I said, this is going to go ahead and set us for the course for today. So we're going to think back way to Algebra 2, Algebra 1, when you talked about end behavior, and that's basically saying, hey, where are the arrows going? Now, when we go ahead and we get a lovely little calculator out, we have a lovely little coordinate plane. It looks something like that in my horrible drawing. And then we have this. Well, I didn't mean to draw my arrow. Let me try that again. It looks like this. So end behavior is just saying, what is the graph doing basically as it leaves our screen? Is it going up or down? So as we look at this, we're going to take a look right here. This is a parabola, and because my a is negative, that means that parabola is going down. So what we would say our end behavior is, well, this is going down on the left-hand side, so we're going to say that's going to negative infinity. And on the right-hand side, it's also going down, which is going to negative infinity. So how do we write this? Well, this is where we're going today. We're going to say if x is the left-hand side, this is just a fancy way of saying the left, then our y part, which is f of x, is going down. So this means down. So as x goes to negative infinity, that means left. F of x, which is your y, that's what it's asking. What is the y doing? It's going down. Those arrows are pointing down on the left-hand side. On the right-hand side, I'll do that here in pink. That is also going down. So we're going to say as x goes to positive infinity, which is on the right, what is that arrow? The arrow is also going down. So we're going to say it's going to negative infinity. Boom. And we're going to talk a little bit more about that today, but that is our review. This is getting the right mindset for our notes today. So I'm going to erase this. So hit pause if you need to, because I need some space to start talking about our goals and our polynomial functions. So our goal today is to identify polynomials. What is a polynomial? What does it look like? What doesn't it look like? Because it looks like a lot of things, but there's a lot of things it doesn't look like. Then we're going to talk about the end behavior, which is just those arrows again. And then we're going to talk about zeros. Now, zeros are uber important, and we're going to do a couple of different videos and lessons on finding zeros in the coming days. So keep this concept in mind. All this stuff is good stuff. So a polynomial. Okay, let's break it down. Break it down. Poly means many. Nomials means numbers or terms. So the idea is it's many monomials. Or many terms, many numbers. Think of it as many numbers. So this is a perfectly good way of how to start it out. Notice I got an x cubed in there. I got an x squared in there. This would technically be an x to the 1. And this technically would be an x to the 0. Or a no x, if you will. So what we're going to start with, though, is the most important stuff. Because we're familiar with all this stuff that I did over here. But those are examples of polynomials too. A cubic is a polynomial. A quadratic is a polynomial. But let's look at the notation. So this is a of n and then x to the n. This is called the leading term. The leading term because it tells the graph what it's going to do. It's going to take control. It is the leader. Okay? So that x to the n is the leading term. Sometimes we call that a degree. Okay, so a degree is going to be the highest power or exponent. I should say highest power. I apologize. Or exponent of x. Okay, so it's going to, again, it's going to lead everything. Cool? And then a to the n, that's what we call the leading coefficient. And that's going to be super important because, again, it's saying leading, so it's going to take control. But it's going to tell us some very important things about n behavior. So keep that in mind. Let's do a quick example off to the side. If I have 4x cubed minus 8x to the 5th plus 1,000. So if I were to put this into the calculator, the 1,000 is a really big number, but it's not going to control everything. What's going to control everything is the biggest exponent. So in this case, it's x to the 5. So I would say that my degree here is going to be x to the 5. And then my leading coefficient is going to be that -8 right there. Even though this is first. And basically what this is saying is even though that's first, it's not going to take control. So really what we should have done at the beginning is rewritten this to look like this, because this would be good math grammar, where then we would say, all right, this is my leading coefficient. But sometimes when you're looking at these, you're going to come across a leading coefficient and a degree that is not in the front, it is hiding. So you want to look at everything before we get a jump on it. All right, so let's go ahead and talk more about some polynomials. So all the powers of x need to be whole numbers, and all the coefficients are real numbers. So what that means is no decimals or fractions, and then they all have to be positive. Okay? And then on the next part, it says the graph of polynomials with degree 2 or more are smooth and continuous. So smooth and contiguous, it basically means no right angles, okay? We're going to have stuff that's going to be smooth and continuous like that. It could have a bunch of different graphs. It doesn't necessarily have to be anything specific, but it can't have something that looks like it's making a giant, all of a sudden turn, okay? Think absolute value. So absolute value would be something like this, where we have our v. That would be a not very rigid, that would be a rigid and not a smooth and continuous graph. So that's bad news. Cool? Alrighty. So these are what we call not polynomials or polynomial imposters. So the first one, it cannot be inside your radical. The x can't. Because if you recall, the square root of x is the same thing as saying x to the 1/2 power. So that's not going to work. As we said, it can't be negative. So if you have a -2, no dice. Okay? Also, it can't be in the denominator. Because what does that mean? If it's in the denominator like that, if you recall from our denominator, our exponent rules, if I have x to the -1, that goes down to become 1 over x. So I could have rewrote this as x squared minus 2 times x to the -1. And notice we have our negative exponent again. That's what it comes down to. You can't have an exponent in your exponent. The x can't be the exponent because that's what we call exponential growth or decay. It is something completely different. And once again, no fractions. Alrighty, so we have really looked into this, our polynomials and what there is. So we've identified them. We know what they are and what they aren't. Okay, so now let's go ahead and talk about that other end behavior. So the end behavior, one of our big vocabulary words for the day, is going to tell us what the graph is doing as we move to the left and as we move to the right. Okay, now noticeable notation is this part right here, which is definitely the most common. That's the one we've seen a bajillion times, or this one. And this one is when you just use arrows to point which way it's going. Okay, you sort of slant them a little bit. That's not nearly as common, but mathematicians are lazy and sometimes they'll do that. Okay, but we're definitely going to try to stick with this as often as possible. Cool? All right. So now when you're talking about end behavior and polynomials, we've noticed some patterns, and that's what this table is all about. So what I would do is I would either print this out or start in your notes, put a sticky note. This is super important because this is going to save you some valuable time, and it's also going to talk about some trends. Okay, so if we have an even degree, and obviously that means the largest exponent, so like an x squared, x to the 6th, x to the 8th, anything right here, you're going to notice that these arrows both go up or they both go down. So even degree means that my end behaviors are going to be matching. They're both in positive infinity or they're both in negative infinity. Notice the matching right here. Oh, sorry. Highlighted the wrong thing. There we go. Notice the matching right there. Now, what's not matching is these right here. So let's talk about that. Let's talk about this notation. What this is saying is x goes to positive infinity and x goes to negative infinity. So if I were to draw a coordinate plane really quickly, and I'm going to talk just about the x-axis here really quickly. So as we go to the left here on the x-axis, what we're going to notice is that our values go -1, -2, -3. But as you keep going to the left, we're going to keep getting negative, and the numbers are going to keep getting farther away from 0. We're going to keep going that way till we get to the negative infinity. So when x goes to the left, we're going to call that negative infinity. And we can do the same thing when we go to the right. Our numbers are going to keep getting larger, 1, 2, 3, 4, all the way up to infinity. So this we're going to get to positive infinity. And then we can do the same thing right here. As we go down on the y-axis, this is negative infinity. And then as we go up, this is going to be positive infinity. So what end behavior is asking is, if we go to the left-hand side over here, what is the arrows pointing, up or down? If we go to the right-hand side, over here are the arrows going up and down. So let's go back over to degrees. The even degree, as we mentioned over here, we said, hey, let me erase these so we can get back in here. They match. They're both going to positive infinity or both are going to negative infinity. And then this, where the x, that's just saying what side are you looking at? Are you looking at the right side or the left side? And if you have an odd degree, notice here, they're going to be opposites. One's going up and one's going down. So if it's an even degree, they match. And if they're an odd degree, they're opposites. So how does that help us from here? So these two, if I go this way reading my chart, this is when we're going to have a positive leading coefficient. So if our leading coefficient is positive, both arrows are going up, or the right arrow is going to end high. It's going up, so I call this end high. And down here on the bottom one, this is the negative row. Notice that when they match, they both go down. Both go down when they match. Or we're going to end down or end low. Notice that this ends low. So that's how I remember it. It's up to you guys to build your own way of keeping this straight, but let's go ahead and take a look at some examples. So example number 1, it says use the leading coefficient test, which is essentially just what we told you to do in that little table above, to determine our end behavior. So let's go searching for 1. We need to know its degree. And then step number 2, what's my leading coefficient? Okay, so remember, as I told you, they're not always in the front, but example 1, that's an x cubed. It's in the front, it's telling us what to do. So this is going to be an odd degree. Remember, odd means they're going to go in opposite directions, and it's got a negative coefficient. So remember, that negative coefficient means it's going to go ahead and end low. So it's going to be something that looks like that little squiggles that I did right there. So let's go ahead and do our end behavior rules. So as x goes to negative infinity, which we just mentioned was the left, this left arrow is pointing up. So my f of x is going to a positive infinity. Then when x goes to the right, as we mentioned before, let's look at that right arrow. That right arrow is pointing down, so f of x is going to go to negative infinity. Okay, so again, this is always going to be exactly the same. It's those other two for the f of x that are going to change. So example 2. Example 2, check this out. It's hiding. It's in the middle. So what we should do in good math grammar is rewrite this negative 2x to the 4th plus 4x plus 1. You don't have to, but good math grammar. Now let's look at our degree. Our degree is even, so they're going to go ahead and match. That's even. Let me help if I spelled it correctly. And then negative, once again, means that they're going to go down. So it's going to be something like this. Alrighty. So, ladies and gentlemen, boys and girls, we're going to say from the left-hand side, it's going down. And then on the right-hand side, it's also going down. Booyah. So just to pause really quickly, notice that on number 1, it was odd, so these were opposites. Notice the opposites. Here it was even on number 2, they match. Easy peasy. What I want you to do is I want you to hit the pause button and try number 3. See how you do, and then we'll go ahead and see how you did in just a second. Alrighty, unpause. Let's take a look. So our leading coefficient is this bad boy right there. So it's going to go ahead and be even. It's going to be positive. So they're going to match. Okay? So what I'm going to do is I'm going to use that other notation. Say both of our arrows go up, or if you wanted to make sure you did it right, as x goes to negative infinity, f of x goes to positive infinity. And as x goes to positive infinity, f of x also goes to positive infinity. Booyah, grandma. Alrighty. End behavior, wonderful. Now we're going to go ahead and tackle the zeros. Like I said, that's something very, very important. Okay? The zeros are the values of x for which f of x equals 0. Graphically, the zeros are where they cross the x-axis. Super important. These are also known as answers, solutions, or roots. I call them the ZARs, and that's zeros, answers, roots, and solutions. They mean the exact same thing. They're all do the same process. Okay? To find our zeros, we're going to set f of x equal to 0 and solve. We call this the zero product property, which is kind of interesting. Because if you take two numbers and you multiply them by 0, okay, either A or B has to be 0. Okay? And we'll come back to that in just a second. So, multiplicity. Multiplicity looks like a simple word. Just think of it as, do we have any repeats? Okay? Look for repeated factors. If it just has one factor, the multiplicity is 1. If it's got 2 factors, it's twice. In 3 factors, the multiplicity is 3. Sometimes we call these double roots. And this might be triple roots from Algebra 2 honors. But we're going to call them multiplicity for today. Now, here's some important stuff to note also, is that if you have odd multiplicity, then it's going to cross the zeros. So if I were to go ahead and draw a coordinate plane, when I mean cross, I mean it passes through. Whoop. Okay. Now, if it's an even multiplicity, the graph is going to touch it. I call this a bounce when I teach Algebra 2. But to go ahead and draw that really quickly, it's going to basically hit the 0 and then stay on the same side of that axis. Okay, so it's either going to cross or it's going to bounce. Okay, now what's important to note is that the higher the multiplicity, so if you have multiple factors, what the graph is going to do is going to be flatter, or it's going to flatten. So if it only touches once, it's going to go hit it and then come down really, really quickly. If it hits a bunch of times, it's almost going to look like it levels off for a while and then comes back down. So you can see this is like once, and this might be like something like 5 times. Okay, so just a little heads up there. So we're going to go ahead and find some zeros. And so we need to find the multiplicity of each one. So zeros, what you're going to do is you're going to need an x. That's what we're looking for. So when I say an x, I'm going to set this part equal to 0. So I'm going to get x minus 2 is equal to 0. So x equals 2. And then I'm going to go ahead and set this part equal to 0. X plus 4 is equal to 0. So x equals negative 4. You with me? Now, I'm not going to do this 3 because there's no variable. If there was a variable, I would treat it the same way. Okay? Now, it also says the multiplicity. So because there's no powers there, our 2 is only going to be once. But since I have a squared here, that means it's going to hit that twice. It's going to count for 2 zeros. It's going to be a bounce. Okay? Where the x equals 2, it's going to pass through. X equals negative 4, bounce. All right, let's look at our next one. So I have plus 3. So x plus 3 is equal to 0. So x equals negative 3. And that's going to have a multiplicity of once. And then over here on the second part, I'm going to go x minus 7 is equal to 0. So x equals 7. And this is going to be thrice, or 3 times. Alrighty. Now, as you take a look at this other ones here, you're going to notice that these are not factored for us like the previous ones were. That's not very nice of them. Okay? So we're going to have to factor them. So the first thing I want you to do when you factor is you always want to see if you can't find a GCF, a greatest common factor. Okay? After that, grouping. You're going to factor by grouping. If we do one of these factor by grouping ones here on number 7, if you have no idea what's going down, you want a YouTube grouping so to make sure you're all good. And then last but not least, which is going to be important for us, is I want you to identify perfect squares. We don't always see them, but they will be hidden in there, and we'll need to keep going. All right, so on number 6, we have a GCF, so I can take out an x out of every single term. So I'm going to get x, and then x squared plus 6x plus 5. And then if you recall, we say what 2 numbers multiply to 5. We use the x as the graphic organizer. What numbers multiply to 5? We'll go ahead and hit multiply right here. And then add to 6. So that's obviously going to go ahead and be 5 and 1. So this would be x plus 5, x plus 1. And then I can't forget my GCF that I took out at the beginning. So let's go ahead and take a look at each one of these. So this is going to be x equals 0, x plus 5 is equal to 0, and x plus 1 is equal to 0. So here are our zeros. Boom shakalaka, those right there. And since they all are, so they all have a multiplicity of 1. Because they only have 1 parentheses, nothing squared. All right, let's go to this next one. So on number 7, no GCF, so we're going to go to grouping. Grouping, think 4 terms is usually how you know when you're probably going to start by grouping. And we have 1, 2, 3, 4 terms. So parentheses around the first 2 and then the last 2. And this is basically GCF 3 times. So this has an x squared in common. So when I divide that out, I'm going to get x squared, x plus 7. On the right-hand side here, we're going to have a negative 4 in common. So when I divide that out, I get x plus 7 with a negative 4. Then the finishing touch of grouping is you say that they have a parentheses in common. So try to not get too overrun with my work and my colors here. So this is going to become x squared minus 4 and then x plus 7. Well, hopefully your spidey sense is going off because you're going to look at that saying, hey, that's an x squared. We haven't seen a parentheses look like that when we factored because that's a perfect square, so we can keep going. So the 2 numbers that multiply to make a negative 4, but the middle term will cancel out, is x minus 2, x plus 2. And then that other term is going to come down. So I'm going to get x equals 2, x equals negative 2, and x equals negative 7. Okay, and again, all the multiplicity here is going to be 1. Alrighty, we have 2 more examples here. So in this one, I have 3 terms, so it's not grouping yet. I call this x box, but some people call it a hard trinomial. But we take our 2 and I multiply it by 3. So 2 times 3 is going to be 6, add to a negative 7. So if we look at those factors that multiply that, that's going to be a negative 6 and a negative 1. Then I split my middle term. Again, if this is all French to you, you want to go ahead and YouTube grouping. So I'm going to get 2x squared, split the middle term. So then we'll go ahead and do grouping at this point. So take out a 2x, and we get 2x, x minus 3. And then I'm going to take out a negative 1 on the second one, and the reason is I want my signs to match in those parentheses they have in common. So now we're going to say they have an x minus 3 in common. So I'm going to get a 2x minus 1 and an x minus 3. So, ladies and gentlemen, boys and girls, we'll set both of those equal to 0 to find my 0. So 2x minus 1 is equal to 0. So 2x is equal to 1, and x is going to be 1/2. And then x minus 3 is equal to 0, so x equals 3. There's our answer on that one. Woo, Lordy! One more. We're almost done. I apologize for the length of this video. This is the first time making a trig video, so I apologize that this took a little bit longer. I'll start to make the other ones go a little bit shorter for you so you're not here for a half hour. All right. So on this one, we're taking a look at saying, all right, we have a GCF of x squared, not 4 because 4 doesn't go into the leading coefficient. So x squared, and then x squared minus 8x plus 16. We'll factor just this parentheses part right here. So what 2 numbers multiply to 16 and add to a negative 8? And that'd be negative 4 and negative 4. So I'm going to get x minus 4. X minus 4. I don't have to do grouping here because I don't have a leading coefficient of 2 or more. This is a leading coefficient of 1, so we can go straight to our parentheses. Bring this x squared down. So this means I'm going to have 2 at 0s, so this is going to be a double. And then I have 2 at 4s, so this is another double. Alrighty. Ladies and gentlemen, it took a little time with those factoring basics and finding the zeros. It's important. It's good stuff. Make sure to come back to this video if you have any questions. Come see me in the back of the leadership room if you need any help. I'm here for you. Have a wonderful day.